Hello, my name is Holly Morrison, and I am excited to share with you some of my results for my poster titled Loss of NF-kB-Inducing Kinase Increases Susceptibility to Colorectal Cancer via Top-Down Tumorigenesis following Diminished Regenerative Capacity of the Stem Cell Niche, which will be held during Session 2 of the Tissue Stem Cells and Regeneration track on Thursday, June 15th from 10:45 to 11 a.m. Here's an overview of my poster. For a little context, I study an inflammatory subtype of colorectal cancer, being colitis-associated colorectal cancer. The overall objective for this work is to identify the cell of origin for CAC, with there being two schools of thoughts for colorectal cancer development. One being the bottom-up model, in which mutated stem cells give rise to cancer development. However, there's an emerging interest that has focused on the top-down model, in which chronic inflammation causes dedifferentiation of intestinal epithelial cells to a stem-like state and tumor formation. As you can see, colonic crypts are multicellular structures that line the colon. Under normal physiologic conditions, stem cells are located at the base of the crypt and terminally differentiate into epithelial cells that extend towards the top of the crypt. The signaling pathway that we center our attention on is the non-canonical NF-kB signaling pathway, which requires stabilization of the NIC protein for signal transduction of this pathway. Loss of non-canonical NF-kB signaling via conditional deletion of NIC in intestinal epithelial cells results in increased susceptibility to tumorigenesis, with increased tumor formation occurring and increased staining of proliferation that extends beyond where stem cells typically reside. In order to rule out involvement of a hyperactive stem cell compartment in CAC development, we were intrigued to find that colonic organoids generated from individually isolated intestinal stem cells were significantly smaller following deletion of NIC in comparison to the healthy control and a positive control for CAC. Therefore, intestinal stem cells actually had diminished regenerative potential. Culminating our results so far, we conclude that loss of NIC predisposes to colorectal cancer, as intestinal epithelial cells, rather than intestinal stem cells, have an increased proliferative capacity. I hope you join me at my poster number 1010, Thursday, June 15th from 10:45 to 11 a.m. so we can continue this conversation and look at other mechanistic studies I conducted to culminate this data in generating our working model. Thank you and goodbye.